Detectable problems: compressor either dynamic or positive displacement can experience a variety of problems, but there are relatively few diagnostic tools to identify them, except in cases where vibration is the issue. A thermodynamics analysis of a compressor is the most straightforward way to determine its health. However, this requires that specific instrumentation be installed on the unit. Thermodynamics analysis algorithms were discussed in detail in Chapter 2, Compressor Theory. Vibration was discussed in Chapter 8. Fortunately, many problems can be avoided before they become costly. Most of these problems can be avoided or minimized with proper and timely preventive maintenance. Obviously, not all problems can be avoided. Some problems are inherent in the design. These fall squarely on the shoulders of the manufacturers. As a rule of thumb, a problem that becomes evident during the first 12 months of operation will be covered under the manufacturer's warranty. As used here, manufacturer also applies to the packager. The packager is a third-party company that installs the compressor, driver, electric motor, gas engine, gas turbine, or steam turbine. Various vessels, valve, piping, lubrication system, and controls on or adjacent to the main skid. The packager, often referred to as the original equipment manufacturer (OEM), has a pre-arrangement with the main component compressor driver manufacturers to package its equipment. Usually, this arrangement includes an exclusivity agreement and price discounts. In most all cases, the major equipment warranty is a pass-through from the specific equipment manufacturer compressor drivers. These are exceptions, but once the unit has operated successfully for approximately 12 months, any problem that surfaces is usually not covered under the manufacturer's warranty. When equipment has not operated successfully during the first 12 months of operation, it is imperative that the owner, operator, and the OEM work together to identify and resolve the problem or problems. When a problem becomes evident, regardless of the compressor's age or runtime, the following basic questions should be addressed as soon as possible. Mechanical problems are associated with vibration, sound, or leaks. Air, gas, water, oil. As such, mechanical problems are self-evident, although the cause may not be obvious. The symptoms are: electrical problems are associated with high voltage or the electric components, motor starters, and switch gears, or low voltage to the instruments and control systems. Diagnosing electrical problems is not easy as diagnosing mechanical problems. However, once the problem is identified, the fix is relatively inexpensive. Performance problems usually result from mechanical deficiencies within the compressors, engine or turbine driver, and electrical problems with the motor driver. These problems may or may not be immediately evident during operation, but they will lead to equipment failure. This type of failure is usually costly with regards to replacement parts, labor, and downtime. Sometimes downtime is the most expensive result of the failure. Upon installation, run the unit to design speed, record the unit vibrations signature at several points throughout the expected operating range, perform a gas pass analysis at several points throughout the expected operating range, record temperature on the compressor not monitored by the control instrumentation, such as suction and discharge valve, covered temperature, cooling water temperature, make note of the different sounds emanating from the compressor during startup shutdown and at normal operating speed. After the unit has successfully at a stable temperature for at least 4 hours, shut the unit down and inspect the unit with minimum disassembly. Do not remove any close tolerance or close fit components. An axial compressor, such is the most is the single most severe expansive failure resulting in damage to the bearing and seals and sometimes to the impellers, diaphragm, blades, and vanes as shown in Figure 11.2. Signs of surge are vibration, gas flow, instability, gas pressure, and temperature fluctuation, and audible huffing or whooshing sounds. Surge occurs very rapidly and it can only be avoided if proper control techniques are applied. Compressor fouling. Indication and corrective action. A compressor efficiency drop of 2% is indicative of compressor fouling. This can be calculated as shown. For the field engineer or operator, compressor fouling is best indicated by a 2% drop in compressor discharge pressure at constant speed and load or throughput. Another indication of fouling is a 3-5% reduction in load or throughput capacity at constant compressor inlet temperature or ambient air temperature. Corrective action. Dynamic compressor equipment manufacturers normally specify cleaning agents. Typically, a liquid wash is specified in extreme cases. Complete disassembly may be necessary to clean the compressor. In addition, reciprocating compressor fouling due to either debris or liquid in the gas may result in damage to the suction or discharge valves and the piston rod. Damage to the valve will manifest itself as an increase in temperature of the valve covers. Rod damage may be detected during operation as nonlinear movement of the rod as it passes through the gland as at the crosshead cylinder interface. Loose piston. The installation of the piston rod onto the piston is a delicate procedure requiring a special lubricant, a special technique, and often special tools. If not properly installed, the piston may become loose on the piston rod. This will result in the piston hitting the end wall. Bearing clearance. Excess bearing clearance can result from improper bearing installation or from general and bearing shoe wear over a period of time. In either case, the effect of bearing looseness can be detected during operation by checking the bearing whirl orbit. Hydrodynamics bearing whirl orbit would be checked. Reciprocating compressor valve. Due to the stresses on the valve plates during normal operation, suction and discharge valves are the high maintenance items in reciprocating compressors. Valve plate failure will have a negative impact on compressor performance. Gas path analysis coupled with direct measurements of the valve cover temperature is the easiest way to detect valve plate failure. Corrective action. Periodic gas path analysis to monitor compressor performance is the first step in detecting a problem.